Hello YouTube viewers, welcome to my show Rocket Monday. In today's episode, we're gonna take a closer look at Falcon Heavy. So let's dive right into it. So you have to understand Falcon Heavy is an orbital class rocket, so it actually goes to space and it's classified as heavy lift. Basically anything that exceeds 30 ton is classified as heavy lift. In some countries it's rated at 50 ton, but that's the rough idea. To give you a context of that, understand this space shuttle has only carrying capacity of 30 ton. So this has more carrying capacity to space than space shuttle. And it can put upwards of 40 plus ton in low Earth orbit in reusable mode. Be aware of that. And if you want to just expand it, basically don't recycle or reuse any of the core boosters, it can send upwards of 60 tons. That's what everybody is going around. It can put 60 ton. Yes, that's absolutely true. However, that's in expendable mode. So basically all three would be spent. Now, as of now, as in 2019, so far, this is the most powerful rocket in use. There have been more powerful rocket, basically Saturn V, but as of now, this is the most powerful rocket in use. And to give you a context, this actually has the same engine output as Saturn V. However, because of the design, because it's basically the design is very inefficient, it does not have the carrying capacity of basically Saturn V. It also has 5 million pounds of thrust. That also had 5 million pounds of thrust. So, and it is very cheap. Now this is the bread and butter of SpaceX, basically making cheap rocket. Now to give some similar, basically not even close to this, basically similar performance, you have to spend upwards of $400 million bare minimum. They can give you expendable, so basically highest capacity at $150 million. So they are quite cheap. So what was the idea of Falcon Heavy? Now you have to understand, SpaceX is not ancient company. It was created in 2002. So only in 2 years under their construction, they literally started thinking of the idea of Falcon Heavy in 2004. Now it was revealed to the public in April 2011. So it's a kind of older system. Now design of Falcon 9 was first built for, as in Falcon 5. Falcon 5 Heavy was first thought of. Then they realized Falcon 5 is not good enough. So they went to Falcon 9. Then the whole Heavy project, basically Falcon Heavy project, was moved to Falcon 9 using Falcon 9 as core rather than building Falcon 5, basically 5 engine variant. So 5 engine variant was scrapped. So you have to understand there has been a lot of redesign in this structure. Now the idea is very simple. You take one center core, basically one stage one, you reinforce it. You can't just use any stock. You reinforce it so it can handle the structural load, and then you strap two normal ones. Now the other two, basically Falcon 9, the booster stage, those are normal. There has no special modification done to them other than putting nose cone and having side clamps. So the two side booster, they are more or less the stock. They are more or less stock. However, the core that you see in the center, that has been considerably modified, and I mean on a structure level. It's not like it has extra clamps or things of that nature. It's thoroughly rebuilt to handle that structural load. Now, this is one crucial aspect that people miss, is that the payload fairing, basically what you have in basically the payload volume, is still limited to Falcon 9, basically because they are recycling everything from Falcon 9. They are still limited by that payload fairing. So even if, let's say, a rocket can carry 60 ton, but your 60 ton payload requires a bigger fairing, SpaceX will reject your contract. You have to go to Atlas series. And to give you the idea, like when this idea came to mind, that time they were launching Falcon 1, this tiny rocket. After that, Falcon 9 version 1 was launched, the first one that actually made to space. Then version 1.1, then there was version 1.2 full thrust, then there was this Falcon 9 Block 5. So right now what you saw recently launched was Falcon 9 Block 5 used. They were not using Falcon 9 Block full thrust variant. So basically they are pushed it to the maximum. That's why I'm saying there has been a lot of redesign. It's not a core concept that they just ran with it. This is one good thing about SpaceX, that they redesign. They are not like NASA, where you can check my video about it, that they will be like, okay, this is one thing, we're never gonna let it go. So they do very good things about this. Like if there is a better design, they just move to it. So they directly bypassed Falcon 5, which was meant for 5 engine variation. They directly bypassed it, which admittedly helped them a lot. So this was the idea of Falcon Heavy. Now there is a core problem with Falcon Heavy. Now the biggest problem with Falcon Heavy is that idea was very old. That time, as in Falcon 9 version 1 only had carrying capacity of 9 ton and it was not even reusable. But Falcon 9 Block 5 has 22 in reusable mode. So understand this, like the rocket literally became twice as powerful while remaining at the same size, while also becoming cheaper, while also becoming quick to refurbish, while actually having the ability to land autonomously. So that thrown everything out of whack basically, because they keep upgrading basically Falcon 9. That Falcon Heavy kind of became, why do I need this? Because 22 ton is very big. To give you a context of that, International Space Station segments are of that size. There is no satellite that is 22 tons. Like there may be some military spy satellites, but other than that, most satellites are generally 8 to 9 ton, and those are for geostationary. So these puppy are very powerful, as in Falcon 9 itself became so powerful that the need for Falcon Heavy went down considerably. So that's why you can see like there have been like freaking 15-16 launch per year for Falcon 9 considerably, and they keep increasing. I think in 2019 they're supposed to launch upwards of 30 launches with Falcon 9. So these are happening. There are a lot of demand, lot of interest in people about this rocket. However, for Falcon Heavy there has been only few demands, and most of them are coming from what we call Department of Defense, and others are geostationary satellite. Now this aspect you have to understand. This is why I mentioned the payload fairing, because they are reusing it, everything basically from Falcon 9. They do not have clearance for 60 ton. They cannot actually put 60 ton. Basically, if you put 60 ton lead weight on top of it, it's like, okay, this is 60 ton, just send it to space. It cannot do it because it will collapse under its own weight. It's not built for that. When Saturn V was built, they made sure that structure can handle 150 ton loaded on top of it. This does not have that luxury. It's way too thin. That's why BFR has been redesigned from ground up to actually have that diameter, because the diameter is like a pencil. So that is a crucial aspect of it. It cannot tangibly carry. It has the engine thrust, but it cannot tangibly carry that much. Now of course they could reinforce it again and again until they reach that point, but you also have to understand every reinforcement come at a penalty of weight, so they will lose it. So I think if they really try, they can put upwards of 50 tons to low Earth orbit, but not more than that. And as of now, the heaviest lift SpaceX done is from Falcon 9, that was 9 tons. So we really don't expect them to put 60 ton using this. And on top of that, the launch pad also gets, because the launch pad is owned by government and they are getting it on a lease basis, they don't have the clearance for it. They can get it, like if let's say tomorrow they need something for, let's say 12 ton, they can get the lease if they want to. But as of now, their lease is, I think, is limited to 10 ton. This could change. Like if tomorrow Elon Musk is like, hey, our rocket has been upgraded, we want more launch clearance, they can get it. So that's not an issue, but be aware, 60 ton, you will never hear that. You will never have a scenario where, okay, Falcon Heavy is gonna carry 60 ton to low Earth orbit. That's never gonna happen. Now that's the problem. So what does it have? Like if there are so many problems, why the heck they are still keeping it alive? The USP of it is what we call high speed insertion. So let's say you put something in orbit and then you have to put it somewhere else. Basically, let's say in low Earth orbit, you want to put it to geostation, or you want to send it to Pluto, or you want to send it to Mars. In those sort of scenario, that extra capacity that rocket theoretically have really translates. That it translates into higher velocity. So basically your second stage will have extra speed. Now it may only get, let's say, 2 kilometers per second extra, but when you are traveling at, like, let's say 11 kilometers per second, 2 kilometers per second extra is a lot of thrust. So that is tangible. That helps SpaceX a lot. That's why many geostationary satellite, they really want to use this, because geostationary satellite have their own rocket engines built into them. Because if they are launched from basically Falcon 9, they do not have enough that it can, circularize the orbit. It can go to geostationary, but it cannot circularize the orbit. To circularize the orbit, onboard rocket motors do a little bit of orbit correction. Now that's not a big deal, but if you are sending the same payload, same thing, as in like 9 ton is the capacity of Falcon 9, and this also has, like, I think 11 if pushing it to the maximum. So let's average it out. Let's say both can send upwards of 8 ton to low, or 10 ton to low Earth orbit, 10 to geostationary orbit. You will have a scenario where this rocket can put it and circularize the orbit. That is the crucial aspect. That's why geostationary satellite really want this. That will allow them to circularize the orbit using the rocket itself instead of using onboard fuel from the satellite. That allows them to reduce the size of rocket that is in the satellite. That helps them increase the payload, actual payload capacity, actual electronics that will make them money. And this also makes them, give them leg room. Let's say they use the same satellite. Let's say they use the same satellite that could have done the orbital correction themselves. They save that fuel. That allows them longer lifespan in orbit, because in geostationary orbit you must remove your satellite. You cannot be like, okay, my satellite was for 20 years. No, you have to remove it. So how they remove it? They put it in what we call graveyard orbit. You can check my video about orbits here. So basically they push it away from the usable spot. So to push that away, you must have rocket in the satellite itself. That is the USP of this, that it can carry on reasonable price a very heavy satellite to geostationary orbit, and your satellite would not need big rockets. On top of that, it is very cheap. That at the end of the day, it's about money. Like if you are saying that I can do something for $300 million less, people are like, okay, take my money. It's as simple as that. Now range, now because I already specified, it has high speed insertion. Now if you send Falcon 9 to Mars, you can barely get upwards of 3 to 5 tons, barely. This puppy can send upwards of 16 ton. So this is the aspect, like you don't expect them to push 60 ton into low Earth orbit. However, do expect them to put 10 ton to Mars. This is their bread and butter. This is what actually is the USP of it, that high speed, because they are gaining like that extra delta V while going up using these two boosters. That is helping. That is their USP. So do not expect that it is a heavy lift rocket. Think of them Falcon 9 turbocharged. So what I can expect in the future. However, as of now, I checked the dossier, or basically I checked the launch schedule. There are 5 launches already scheduled for it, but BFR will replace it. That's the idea. Now, will SpaceX keep using Falcon 9? Obviously, Falcon 9 is very perfect. Like it's one tool that can do it all. So Falcon 9 will be there. However, BFR won't. Falcon 9 version heavy won't be used that much, because at a point it won't make sense, because if they have to develop BFR actually leapfrogs it ahead enough, because Falcon 9 is actually like, let's say 90% there, and Falcon Heavy adds only 10% more. It's not justifiable enough. Basically, there is not enough gap. It's like you bought something and you bought something little bit better. It's not enough of a gap, but BFR will have enough of a gap that people will like, okay, it makes sense. So as of now, Falcon Heavy is a basically stopgap measure, which barely is going to be used. Most of them are booked for spy satellites and big geostationary satellites. That's the main use case. So only few launches would be there. So compared to Falcon 9, which will be like using upwards of 10, 20 to 30 launches per year, you will barely see 3 to 4 launches from Falcon Heavy. Do not expect to see Falcon Heavy every other month, same way you are seeing Falcon 9. So that is the core aspect. Falcon Heavy is a very stopgap measure kind of scenario, because they were developing this way back then, and that time Army showed interest that if you build Falcon Heavy, we'll give you a Department of Defense clearance, which is needed for basically confidential satellites. So that is why Falcon Heavy has been built. It has been built because the idea is very old and they did not want to throw it away. Now once they built it, then they realized it's not that awesome, because Falcon 9 kept upgrading. The Falcon 9 itself can beat Falcon Heavy in terms of price and in terms of other things. So don't expect a Falcon Heavy to become the next headline rocket. Falcon 9 still is the king. So this was my presentation on Falcon Heavy. I hope you liked it, learned from it. In that case, please leave a like. If you didn't like it, don't worry about it. You can dislike it. I would urge you to press dislike button twice to show me your extra disappointment, and leave a comment, because I reply to all of them. Also click the ad shown in this video. That will directly help me. If you can also subscribe, press the bell icon if you're free, and as always, thanks for watching.